Good morning. It's 9 a.m. in San Francisco, and I'm Patricia Dugan. I'm very excited to bring you today's meetup. We have the Mesh developer team here today. Let's start with a couple of things I like to say at the beginning, and then we'll take you into exactly what is super exciting about our meetup. My name, Patricia Dugan. I am the head of community at Containous, and I manage all of our marketing initiatives that are focused on our beautiful open source community. And today we have a Traefik online meetup, which is focused on Maesh. And Traefik online meetups are specifically created to show you how people and companies are using Traefik to solve interesting technical challenges. So today will be no different from that. You can follow us on YouTube and subscribe to that so you can get a notification every time we have a new one come out. And they're pretty dope. So one thing I need you to know, please, is that we have a blog that will tell you about all of our yummy stuff that we're up to. So I just put that in the chat box. It's blog.contain.us, containo.us. And then you can learn on that what we're coming out with, where we'll be, interesting things that we're doing. So let's tell you about the next meetups we have going on. So as you know, today is a beautiful meetup with our lovely team who have designed Traefik and also are working on Mesh. So we're going to talk all about that today. Next week on the 24th, we have moving to microservice architecture using Traefik for fast and low risk deployment with Sylvain Combrac of Les Tiliou. I forgot to practice my French before this. And he is a full stack developer there, and we're going to sit together. He's going to show us a couple of demos and teach us how to use Traefik for service management as well as Docker Swarm in order to manage their microservice deployment and keep things going speedy and error-free. Next, we have November 13th. This will be another exciting meetup. It'll be Traefik 2.0 online meetup, 100% community driven. I personally am super stoked on this because it will be built around questions that came directly from our community. So it is not us talking, it's us talking about what your concerns are, what your thoughts are, what you'd like to understand. And then on December 12th, I'm also super excited to have a meetup with Katie Gamanji of Containous International. And we're going to talk about how they're using Kubernetes and Traefik in their deployments over there at Containous. So that will be a wonderful, super cool meetup. Now, next, let's get on with the show. Today, we have the wonderful Mesh team. Daniel and Michael will be guiding us and talking to us about Mesh, our simpler service mesh. And the way the questions are going to be handled today is you can enter them into our chat box or into the module, and then we'll answer your questions towards the very end. During the session today, what we're going to do is we're going to provide some links to you, some dashboards, so that you can play with the demos in real time with us and see actually the analytics shift as you put in your inputs. I will also share an online GitHub link to our slides so you can take a look at those on your desktop. And of course, we'll be screen sharing as well. And then, so that's what we're going to talk about today. We've got some sweet demos. We're going to talk about Go applications. And my friends here, I'm so lucky to work with them. They're super smart and fun and cool. And with that, I'm going to stand down. I'll be in the chat box if you need me. And let's watch and enjoy the show. And again, thank you for coming here today. We really appreciate it. And this video will go to YouTube after if you can't stay for the whole show. So thank you. And Michael and Daniel, it's your turn.
Thank you very much, Patricia. So first of all, thank you to everyone to being here. So today we'll discuss about Mesh, the new product we have launched a few weeks ago. So first of all slides are available online. There are a small tutorial to explain you how it works easily. So it's on containous.github.io. Patricia can share the slide on the chat. So My name is Michael. I'm a Traefik maintainer since 2 years now, and I am working with the sales department and I am a solution architect at Containous. I am available on Twitter and on GitHub too.
Hi, everyone. My name is Daniel Thompson. I'm one of the oldest Traefik maintainers, and I'm currently a developer with Containous. I'm also available on Twitter and GitHub as well. So unfortunately, Manuel was not able to make it today. He's feeling a bit under the weather, but he's a solution architect with us at Containous, and he can be accessed via Twitter and GitHub as well.
So let's speak about Containous. So Containous is a company behind Traefik, Maesh, Yagi, and Traefik Enterprise Edition. Today we'll discuss about Maesh. So we are about 30 people, mostly in tech part, and we are working in distributed mode. We are around 7 countries, something like that today.
So we'll get this meeting started off by basically going over what the heck is a service mesh. Lots of people are a little unsure as to what a service mesh actually consists of, what its job is, what it's supposed to do. And one simple definition is that it's a network layer, and it's supposed to be able to help you ensure that your communications are fast, reliable, and secure, and provide you more than what your basic network layer currently provides. So on the next slide here, there are some benefits to using a service mesh. The biggest one is that it provides extended functionality. So this is going to give you things like load balancing, service discovery. These sort of things are often not implemented as a base network. The other thing is that it's going to give you centralized configuration instead of having to implement features across services. So what this means is instead of having to have load balancing or canary deployments configured on every microservice in your infrastructure, you can have a service mesh handle those feature implementations, and they should be pretty seamless to implement across your infrastructure. And that leads right into the next point, which is it provides an abstraction layer for network functions. Your application shouldn't need to know that there's a service mesh running. They should just be able to connect east-west as they would in a non-service mesh environment. And the last benefit would be something like traffic control, where you'd be able to control how the traffic flows east to west and have more insight as to what's going on. So on the next slide, we're going to go over some challenges. So there are some challenges with working with service meshes. The first one is that the current solutions can be complex to understand. Networking in Kubernetes and in other orchestration platforms often involve multiple virtualization and abstraction layers. And if you're not quite comfortable with working in those environments, the solutions can be pretty complex, and how traffic gets routed from one container to another container can be multi-stage, multi-step, and can be quite complex. That being said, those layers and everything can also be resource intensive. Lots of offerings have sidecars that need to be run on every single pod in your workload, whether that is required or not. There's also slowness, which is something that may be encountered as there are more hops and more proxying and more computation time. There's also a risk of being invasive, where if you have a service mesh that is interrupting and rerouting your data without you really understanding where it's going and what's going on, there are people that are uncomfortable with that sort of a situation. And lastly, there's a challenge of lock-in, where if you implement a service mesh that that you have to tune your applications and tune your workloads to, then you're basically locking into that particular implementation rather than having the service mesh work for your workload. Let's look at the next slide here. And this is where mesh comes in. So what is mesh is the big question. Mesh is a lightweight, easy to configure, non-invasive service mesh that allows visibility and management of traffic flow inside any Kubernetes cluster. I know I'm reading the slide, but that's the best way, it's the cleanest and best description that we have. So there's a couple things about mesh that you may or may not be aware of, which we list on the next slide there. It's built on top of Traefik. Now, I assume that most of the people here have heard of Traefik or have used Traefik. Traefik is an open source cloud native edge router, and we've been leveraging it. We leverage it in mesh to be able to provide the proxying required. By choosing a proxy that's production ready, production proven, which not like we're reinventing a wheel, and it gives you more confidence that the system is built to last. Something else that's interesting about mesh is that it is SMI compliant. We won't be going into the SMI specifics in this presentation. We wanted to keep the focus, on the base Kubernetes providers so that we can show what mesh is and how it works in a more simplified environment. SMI is an entire topic in and of itself. We're going to have a webinar in the future where we do go over how SMI is implemented in mesh and give some examples and give some demonstrations. But we want to make sure that we have the base in here. So we can answer questions about it. We'll do it asynchronously, but for the most part, we want to keep the discussion today to just a base Kubernetes provider. And the last part of mesh, which is the really cool part, is that mesh is opt-in by default. It's not an all or nothing. You can install it and have one application in your cluster use it. You can install it and not even use it at all. There's nothing that prevents, there's nothing that is a you have to commit. And in the opposite is also true. You can have mesh installed. You can use mesh and then decide that it doesn't work with, that one of your workloads doesn't work properly with it, or you encounter a bug, or you decide that that's not where you want your resources focused. You can actually shift out of using mesh and continue to use while other services are able to still use it. So mesh has some cool features that are on the next slide there. The first one is that we support OpenTracing and OpenMetrics. These are two of the most requested features from service meshes. So right off the bat, they're supported. We do have retries and failovers. So in a situation where there's a network issue or there's, those sort of things, those can kick in. Same with circuit breaking and rate limiting. We do have those features possible. So you can have, if you have a front end application that you want to rate limit to your API requests inside, you can definitely apply those. Access controls are implemented through SMI. So we won't go too deep into those, but you do have access control to be able to determine which pods can access which other pods through mesh. And then the last important feature is that the installation is really, really easy. It's just a few lines of code. We recommend an installation using Helm, but in the latest release 0.6.0, you can actually template out the YAML yourself and just either pipe it to kubectl, or you can just do a kubectl apply with the generated YAML. So moving on, the mesh architecture is very straightforward. We run one mesh pod on every node as a daemon set, and we have a controller that manages the configuration of those pods. So instead of your pod B connecting directly to pod D here, you would just point your pod B to mesh, and then mesh would route directly to pod D. It does involve one more hop, but we feel that the non-invasive and the observability that it provides is well worth it. On the next slide, there's a little bit of a more detailed view of how the request would work. So using the normal service of pod A, you would request the service and Kubernetes would directly forward the request onto one of the pods in pod B. Whereas if you're using mesh, you just point it at mesh and one of the mesh pods will handle the redirection. And that will allow those features like failover and canary deploys and all those other things. So that's basically the rundown of how mesh works. So I think it's time to hand the mic over to Michael because it's demo time.
Thank you very much, Daniel. So yeah, we'll just try to have a demo. So we will assume that we have a Kubernetes cluster installed. So on my side, it's a Kubernetes cluster installed with kops on AWS in the Europe. So during the demo, I will Patricia will send you some links and we'll be able to access to some application running inside this cluster. So first of all, we have done a presentation of mesh for the communication inside your cluster, but we need to manage the incoming traffic from the internet. So to do that, we will install a reverse proxy. I'm not sure which one I will choose, but I will choose Traefik, I think, today. So I will install the CRDs for Traefik because we'll use Traefik v2. So I will apply my CRDs and I will install my Traefik application. So it's pretty simple. For now, there are a beta Helm chart available on GitHub to help you to install easily. On my side, I have done my own YAML file to be able to install it. So it will create a namespace for Traefik, some cluster roles, cluster role binding, service account, a specific service of type load balancer, a deployment, and some ingress route to be able to access to the dashboard, for example. So let's try to see if the dashboard works. So this is the new interface of Traefik v2, as this is my ingress controller to manage the incoming traffic from the internet. So actually I have 4 entry points defined on one for the HTTP, one other for the HTTPS, one for TCP, and I have exposed also my 8080 port for traffic. So for now, I have only 2 routers, one routers that match all the requests and available only on the HTTP entry point, that will allow me to force the redirect on HTTPS. So, and I have one other router for the dashboard, and this is the router we use today to access to this dashboard. I will also install some monitoring and tracing stack. I have also prepared this thing. So in the monitoring stack, I will install Prometheus and Grafana. And for the tracing stack, I will install Jaeger. And I think I will have access to the different dashboard after a refresh, maybe. Yeah. So all of these URL are available online. So Patricia can share you this information. For example, I will access to my Grafana dashboard and see what's going on it. Okay, and there are a dashboard available. It's Traefik V2. In this dashboard, we will be able to collect data from the ingress controller and also of all mesh instances to have some metrics about it. As you can see, there are some requests arriving on this cluster. Now we have to install mesh. Mesh, we have choose to install mesh through Helm, and we use today a custom repository because we haven't yet published officially the Helm chart. So we have our Helm chart available on GitHub through GitHub pages, and to add the repo, you can use this command helm repo add. The name of the repo will be mesh, and I will refer to the correct URL. Everything is available on the documentation of mesh. So I add mesh to my repositories. I assume that you have already your Helm, your tiller init on your cluster. And I will install mesh through the command helm install in the specific namespace mesh. I will use the name of the Helm chart, mesh, and I will use a custom value for the installation. Before the installation, I will show you the custom value file. So first of all, I will tell to mesh to use the latest Traefik images v2.0. I will tell to my controller to ignore some namespaces to avoid to have too many events from different services, what we don't care about it. I will also force the disable of SMI. For the tracing part, I will not deploy the tracing because by default, when you install mesh, it's possible to install Jaeger and Grafana and Prometheus. I don't want to deploy these tools because I have already installed it on my cluster. But I want to enable the tracing with Jaeger for the SMI part. And I also want to enable the Prometheus exporter on all of my mesh nodes. So I will execute the installation. I will maybe clear my terminal and go ahead. So it will do an installation. So like Daniel explained you, we run the mesh node as a daemon set. We have our controller deployed as a deployment. So we will have one controller and we will have 3 mesh nodes. We have a specific service created to be able to access to the API, and we create our own service account for the controller and the mesh. So kubectl mesh get pods. We will see what's going on. As you can see, we have maybe, okay, they are not all running for now. So we have installed all the mesh things inside the cluster. During the initialization of the controller will check if core DNS is installed in the cluster. If yes, it will patch core DNS to add a new rule and to be able to create a specific entry on the config file. I will just, I don't know why this pod is not running correctly, so I will just try to delete it. And see what's happened. It's taking time. We'll wait a bit. Okay. So we'll continue the demo. So on the Google Cloud, now I have to install some application to be able to have some microservice application. So our demo is based on the Google Cloud Platform repository on the project microservice demo. This is a hipster shop that simulates microservice architecture. So what is the idea behind this project? So today we are all here in the internet, and we will install all of this application inside the Kubernetes cluster. So we will have here the traffic ingress controller to be able to manage the incoming traffic inside the cluster, and the entry point of the application will be the front end. This front end application will do some grPC call through different microservices. And we will also be able to manage some TCP connection with the card service. This service will access to a Redis through a TCP and through the service mesh. So I will start to install the application. So it will create all the microservices. I have to create the Redis one too. Now I have to create the ingress route used to access to my application. So the ingress is a traffic format. It's a CRD. So I can maybe show you this file. This file is an ingress route from the traffic container v1 alpha 1. The name will be front end. I will attach this router to the entry point HTTPS. The matching host will be frontend.mesh-demo.containous.cloud. And I will forward all the requests on the service name frontend. And I will also be able to generate some TLS certificate with my cert resolver default. So this is not the goal today to speak about the new Traefik v2. We have planned to do an online meetup for the Traefik v2 release. So I will apply this ingress. And okay, I have forgot to apply one project, the card one, that's the one that connects to the Redis. So I will apply it. And I will also do some, create a load. It's a small tool that does a lot of requests on the infrastructure. So I will create everything. I will check that my pods are running correctly. So we're just waiting a bit. I have to wait that the whole application starts. When it just crash loop. So I don't know why this one is crash loop. So maybe we can just try to access to the URL. The URL will be frontend. Oops, frontend.mesh.containous.cloud. So it seems that there's something not working very well. So we'll check why. Everything seems to work. No. Okay, maybe I have some issue with my browser. Okay. Let's check the Traefik ingress controller log, because it seems that Traefik doesn't see this new router, as you can see. So I will go get kubectl-n Traefik get logs, get pods. First of all, okay, I have one Traefik pods. So I will check the logs. And oh, I have just killed my window. kubectl Traefik logs, and okay. Okay, it seems that I have some issue with authorization. because I am not allowed to list the ingress route. So I will reapply only kubectl, apply kubectl, apply. Sorry, it will be Traefik, and I have to reply only this one, and I think now it will be okay. Yeah, it will be okay. It's okay. I don't know why sometimes when I reapply airbag that has already applied, I have this issue. I think it's related to Kubernetes. So, and as you can see, now the front end, the hipster shop is available online. So you can easily browse this URL and try to navigate a bit. So maybe I will take this one. I want to pay in US dollar. And okay, I will browse other product now. And so all the requests inside the cluster, like I show you before with the diagram just here. So all the communication pass through the service, the mesh services. So I think if we refresh this dashboard, now we'll see that we have a lot of data inside the cluster. Maybe you can just play with it a bit and we'll see how the things are going.
Michael, is this a good
Yeah.
time for me to share the Grafana link?
Yeah, for sure, you can. Or maybe I can, I don't know. Where is the chat? Chat, okay. I can maybe send to.
I just threw it in there. I just didn't want to spoil the.
Okay, thank you very much.
Okay.
So now all the communication inside the cluster pass through the mesh. So if we resume the thing, so we have an ingress controller, a Traefik v2 instances, installing in Kubernetes cluster that will manage all the incoming connection from the internet. And to manage the incoming the connection inside the cluster, we use mesh. And as you can see here, we have all the front end that has used here. And I will now try to show you the Jaeger tracing, because all the microservices are able to trace a request. One the issue we have today with the tracing, it's not related to Traefik, but it's mostly related to the difference between two projects, OpenTracing and OpenCensus. They are working on something new. The name of the new project is the aggregation of these two projects, and the new project will be OpenTelemetry. So today, Traefik is compliant with the OpenTracing API, but not with the OpenCensus API. So we will work on this part with the team and the community to be able to, in the near future, to be able to be compliant with the OpenTelemetry project. So as you can see here, we can find some trace inside the cluster, and we can see that that the request, a front end just produce request on the product catalog service, sorry, and the shipping service. So maybe I can have a small word about telemetry. So this is one of the big things that will arrive during the next few months, because it's clone native for today. So it's a new project, and it will be a migration of OpenTracing and OpenCensus. It will be in the same product, OpenTelemetry. Today it's in alpha stage for a lot of components, and we will follow these things, and we will improve Traefik to be able to have all of this improvement inside mesh project. That's pretty much it for the demo. I hope you enjoy it, and if you have some question, feel free. Daniel, if you want to add something.
I was just going to ask if you could bring up that YAML from the demo, just to show how you configure an
Sure.
application to access a service through Mesh.
For example, I will show you on Google front-end YAML. So as you can see here, we have the definition of the container, and we, with the front-end application, we defined the value of the URL of the microservice they have to call. And before it was product catalog service on this port, and now it's product catalog service .default.mesh. And when you do a resolution of this domain name, CoreDNS will give you the answer of one Kubernetes service that point of the on the Traefik pods, mesh pods, sorry. And I can.
So that's all there is to it. To use Mesh is just, instead of using your normal service endpoints, you're going to now just use a Mesh domain name to be able to handle all of your requests.
And for example, I will show you how to enable TCP for a service. So it's on the card one. No, it's not on the card. The name of the service is cart. It's not cat, it's Redis, sorry. So this is the installation of the Redis. So as you can see, it's only one deployment with some port 6379, and we are able to read the annotation on the client service, and with the traffic type, we can manage the TCP and the HTTP protocol with Mesh. Today, it's some grPC connection between microservices, and to be able to manage these things, it's also possible to customize with an annotation the scheme used, and in our case, for Traefik, it would be H2C, to be able to do some grPC through Traefik.
Cool. Michael and Daniel, we have a few questions coming out. Did we have more demo to show, or should we move into Q&A time?
Oh, I think it's Q&A time.
Cool, super exciting. Just want to say real quick, good job, guys. That was awesome. Okay, let's get going. We have our first one.
I think I can answer the first two questions at the same time.
Go for it, yeah.
Because there's a lot of question in regards to SSL and TLS between services. So Mesh does not use any sidecars. We don't use any.
Daniel, could we read out the question first?
Oh, for sure. So the first question is, does Mesh handle SSL between services? And the second question is, when using Mesh to connect to other pods, does it use end-to-end TLS? So as I was saying a little earlier, Mesh does not use any sidecars, and Mesh does not. So what that means is your application will make a TLS request to Mesh. But unfortunately, because we don't have any access to, we don't want to modify your application pods, and we don't want to run a sidecar, we don't have access to your root CAs. So we would not be able to handle an HTTPS request with a custom signed certificate. So if you're wanting to do end-to-end TLS within an application, there would have to be a TCP connection, and your application itself would have to handle the TLS, and that has to do with the how certificates are verified. So it's possible to do, but it's not. That's one of the current drawbacks of not having a sidecar. So then next question we have is there a possibility to make Mesh work with Nomad instead of Kubernetes? So right now, Mesh supports Kubernetes only. However, we do plan to bring it to other orchestration platforms such as Docker Swarm and potentially Nomad and again other orchestration platforms. We just want to be able to get a solid working infrastructure and product first, but we do have other orchestration platforms on our radar and on the horizon.
I can maybe
So
handle
then, yeah, go for it.
Yeah. So does Mesh add some unique HTTP header for aggregation? So today, if you go through the ingress controller Traefik and you enable the tracing, Traefik will be able to add a unique header with a unique ID, and you can use this header during all the communication between your microservices to be able to follow the request.
Now, if you're also looking to have a unique header so that if you have logging or you want to filter by some other, right, by label or something like that, that is something that we could probably, that could be extended. I would recommend that you open a feature request on our GitHub product page. So github.com/containous/mesh. And file a feature request there, because that's something that would probably be implementable.
Super cool. Anyone have any more questions? By the way, I want to say hi to my friends Thomas and Trond, and a few more of you, Miko, Kenneth, and I think we lost, Miguel. I know all of you from social media and from our community, so we're super happy you're here. Let us know if you have any more questions right now. I see.
There's a new question here. Okay, I can take this one. So the question is, the Mesh domain name that we use to access Mesh, how is it generated from the service name? Now, normally in Kubernetes, when you're accessing services, the shorthand is service name.namespace. And sometimes you could do service name.names. The full qualified domain name is service name.namespace.cluster postfix. But what we do is we take service name.namespace and then add .mesh at the end. So that's why when we were doing the demo, you saw product cart or whatever, but we needed to add the .default is because we use service name.namespace to build the mesh endpoint. So it's service name.namespace.mesh.
Cool. I personally just want to make sure everyone has a link to our community forum, which I just threw in the chat box. And I'm sorry, there's a lot of linkage today, but it's all useful. And then we have some time for more questions if you like. Otherwise, we'll wrap up soon. So we have the community forum where you can find Michael and Daniel. Like Daniel mentioned, we have Traefik 2.0 meetup coming up soon, and we'll have another one around SMI. We'll also be at KubeCon in San Diego, where you can meet the guys in person, our team in person, and we can chat and really get to know each other IRL. Anyone else have questions? Or Michael and Daniel, do you want to say anything important so everyone has info?
The only thing I would want to end on is the fact that Mesh is an open source project, and as such, we rely on a lot of feedback from users, whether it be something, whether it be feedback from a small project that you're working on at home, or a larger development or staging environment or production environment that you guys are running. So please feel free to, and we welcome feedback and feature requests and such on our GitHub project. We don't know what's important to you guys, to everybody, if you don't let us know. So we do our best to make educated guesses on what to implement. But if there's something that that the community really wants, please let us know so that we can make sure that we prioritize those requests.
Right.
Yes.
Yeah. Hey, Joksha, thanks for your question. Michael, Daniel, and I are super stoked you're here, and it's cool you're late. The video will be sent to YouTube in the next few days. I'll put that link in here again so you can subscribe. The slides I'll share with you right now, and they are available. So, coolio. Anything else, everyone? Otherwise, we're going to call it a day. Oops, Miguel, saving the best for last. Do you want to take that, Daniel?
I just want to ask something more. We are Containous is hiring. So if you want to apply, just run the Containous jobs. And I also want to say thank you to everyone, and everything will be available online on containous.github.io/mesh online meetup for the HTML part. In the source code, you will find the demo too.
So excellent. So the question was that what do clients that require TLS everywhere? How do they use Mesh? So one for the time being, the solution would be to use TCP services and have your application handle TLS or use another sort of proxy within your pods to encode. If TLS end-to-end is a showstopper and the community really wants it, it's something that we've discussed. We haven't implemented at this point, but if that's what the community wants, that's what the community will get. So feel free to give feedback and provide feature requests on our GitHub repository so that we can make sure that we know what is important to users.
All right. I am in love with the fact that we have this amazing meetup today about Mesh. We hope you like the little gopher. We put a lot of love into that. Find us on Twitter or on in the community forum. And I echo everyone else on the gratitude that we have for you spending your time with us this evening, this morning. And we will see you at upcoming meetups. And as we do sometimes, a virtual fist bump to everybody. Don't leave me hanging, Michael. All right, everyone. I think we're good to go. Michael, Daniel, are we good? Wrapping up?
I'm good on my side. Thank you very much.
Yep, good here.
Thank you, everyone. Ciao, ciao. We'll see you again. Thanks.
Thank you. Bye.
Bye-bye.
Bye.